Okay, I'm going to go ahead and start recording from where we just pick up on some of the homework. I want to back up a second and work with you example 5, and then we'll do example 6, and then we'll go into looking at the homework. Is that good? Because yesterday we finished before we had a chance to do either one of those. Okay, so I wrote example 6 on the board, and then I did it. And I don't think anybody else was paying attention. No. See? So we're going to do, this is lesson 2.7. This is technically part 2 because it's day 2, but this is a continuation of the first part that we just didn't quite get finished yesterday. So looking first at example 5, because I think that's a good place to begin. We have a multi-step inequality. That means it's got variables on both sides. It says 13 minus 7x is greater than or equal to 10x minus 4. Okay, 13 minus 7x is greater than or equal to 10x minus 4. A couple of things to remember about solving inequalities. Rule number 1. What was that? Yesterday, huh? Okay, we want to move variables to the left if possible. That was actually rule number 2. That's fine.
Flip the sign if you divide by a negative or multiply by a negative.
Okay, if you multiply or divide by a negative, the sign has to turn around. So if I multiply or divide by a negative number, the greater than or less than symbol changes signs. Yeah? Okay, so we want to go letters left. So that means I'm going to move this 10x by subtracting it from the other side. At the same time that we do that, we could move the 13. And that takes my letters to the left and my numbers to the right. Kind of in the same step here. Is that overcomplicating things for you? Are you okay? So now on the left, when I combine all of those numbers, I've got negative 17x greater than or equal to negative 17 on the right. And then divide by negative 17. Flip the sign. X is now less than or equal to positive 1. Notice that sign switched. Okay, that's the big deal right here. Because I divided by a negative number, then my sign has to go from greater than to less than. So this is a good answer. We talked about yesterday how this might look graphically. If I was going to show x being all the numbers less than or equal to 1, I would demonstrate that on a number line with a closed circle because it's or equal to. Right? That or equal to indicates that I need to close the circle. And then I would shade it in what direction? To the left. And again, if I will move my letters to the left, that's kind of nice because then I can look at this symbol right here and I can say it means to shade that way. Cool? The last thing we talked about yesterday was representing our answer in interval notation, which is to say x is all of the numbers on this interval. So if we were going to do that, what would we say here? From negative infinity to positive, okay, to positive 1. Negative infinity to positive 1. X is representing all of the numbers in the range or on the interval from negative infinity to 1. And then we use symbols. Yeah, so parentheses on the negative infinity side. That indicates that I will go to infinity, but I'll never actually touch it. And then because we are able to be equal to 1, so in the same way that we're equal to 1 in the closed circle, we show a square bracket on this end, and that indicates we're touching 1. It's included in the values. Yeah? Everybody good? Okay, so that's the example we didn't get to yesterday as far as example 5 is concerned. This is example 6. So it's the same train of thought, but this time we have fractions. What? No way. I'll give you a second to get it written down. Negative 3/4 x is greater than or equal to negative 5/8 plus 2/3 x. Yeah? So same idea here. We want those letters on the left side. So we can subtract this 2/3 x from both sides. But I'm not able to combine the two unless what? Unless those fractions have common denominators. So technically you could write it out like this. Negative 3/4 x minus 2/3 x. This is what your textbook does. They write it all out and then they go get common denominators. Is greater than or equal to negative 5/8. Shub, what are you thinking is a common denominator between 4 and 3? 12. So to the first equation or to the first term, what would you multiply by? 3 on top and 3 on bottom. So that makes this first term be what? Negative 9/12. And to the second equation, what are you going to multiply by? 4 over 4, the second term. So I got negative 9/12 minus, what's the second one going to be called? 8/12. Now do I have common denominators where I can combine? Yeah. What's negative 9 minus 8?
17.
Negative 17. Dig a deeper hole. If you had added 8, you would come back up to negative 1. Okay. So we've got negative 17/12 x greater than or equal to negative 5/8. Notice that I didn't take the right side to a common denominator. I don't need to. I'm not trying to add it or subtract it from anything. In this step, what am I going to do to get rid of that 17/12? Divide by 17/12. Okay, when I divide by a fraction, what do I actually do? By the reciprocal. So not only divide by 12 or multiply by 12, also divide by 17. You could do a double whammy and get rid of both at the same time. So we're going to multiply by the reciprocal, which would be negative 12/17. And what does that do for me? Gets me just x. X by itself on the left side. What I multiply on both sides?
Wait, you gotta flip the sign.
Right, because I multiplied by a negative number. So now x is not greater than or equal to. X happens to be less than or equal to. And over here on the right side, what do we have? I have an 8 and a 12 that have what in common? 8 and 12. They're both... They both have a 4. So if I reduce 8 and 12 by 4, how many 4s are in 8? And how many 4s are in 12? 3. So now I've got a negative 5 times a negative 3. That makes a what? Positive 15. I lost it. There it is. Positive 15 over 2 by 17. That's a 2 on the bottom times a 17. 34. That would be your answer. Okay, so we had positive 15 over 34. Questions on that?
No, but wait, like put it.
Okay. All right, so let's go ahead and now look at some of the homework questions. I told you to save number 10 and number 14 for us to do together. Is that good? Are y'all alive? Are y'all awake today? You're so quiet. Huh? Yes. Yes, I like it when you talk to me. So on your homework page that you already did all of these other problems, I want you to write down number 10. And we're going to do it together. I'm about to give it to you. Ready for it? All right, number 10, it says negative 1/2 x is less than or equal to negative 5/4 plus 2/5 x. Negative 1/2 x is less than or equal to negative 5/4 plus 2/5 x. So what's my first move? First thing I want to do. Move the x stuff. Okay, get the x stuff on the other side. So how do I move it? Subtract 2/5 x from both sides. Okay. The issue is that I cannot combine like terms because they don't have a common denominator. So I've just got to write it out all the way expanded like this. Negative 1/2 x minus 2/5 x is less than or equal to negative 4/5. Yeah, negative 5/4, sorry. So only I need a common denominator on stuff that I'm trying to combine. I'm not interested in getting this negative 5/4 to have a common denominator with the rest of it. I'm not going to be adding or subtracting it. So I'm only needing common denominator right here for these x values. So I've got a 2 and a 5. Where do they meet? 10. Okay, so if I need a common denominator of 10, what am I going to multiply the first term by? By 5/5. Remember, I have to do the same thing top and bottom so that I can say that it's legal. I'm multiplying this thing by 1, really not changing anything. But now I'm going to call it negative 5/10 x. What would I need to multiply the second one by? 2/2. So this one's going to be minus 4/10 x. Yeah? Okay. Is less than or equal to negative 5/4. So now we can combine them because they have a common denominator. So negative 5 minus 4. What you got? Negative 5 minus 4. Negative 9/10 x is less than or equal to negative 5/4. Now what's my move going to be? How do I get rid of that fraction by x? Divide by the fraction, which is to multiply by its reciprocal. So negative 10/9, which does what I need it to on this left side. That cancels everything over there. On the right side, I'm going to multiply by negative 10/9, being careful to do what? Flip the sign. Why? Because I multiplied by a negative, right? So now I have x is greater than or equal to. We could reduce it. That's going to be 50/36 if we don't reduce it. Then we could reduce that. Or we could look in here and we could say there's a 4 and a 10. What do they both have in common? 2. So if I divide the 4 by 2, I get 2. If I divide the 10 by 2, I get 5. I've got a negative and a negative, which makes a positive what? 5 times 5 is 25 over 2 times 9, 18. So x is greater than or equal to positive 25/18. If you put that on a number line, you just have some random value, 25/18. What kind of circle would you have? Closed in, shaded to the right. And in interval notation? 25/18 to what? To positive infinity with a square bracket here and parentheses on the right end. Good? Questions on that one, anybody? No? All right, let's go on to number 14 then. Did y'all get 12? We do okay on 12 on the homework? Okay. So 14. Okay, quit doing that. Fourteen says x minus 1 over 3 plus x plus 2 over 5 is less than or equal to 3 over 5. And I think it was Zaylee yesterday. Did you try to find the lowest common denominator on all three of these? Was that you? No? Maybe it was Sophia. It was somebody that was asking, do we need the least common denominator? And in this case, we do. This is different than the last two problems that we worked because I don't have singular coefficients of x that are fractions. I have x grouped into a fraction with a whole bunch of stuff around it. Can you see the difference? Okay. And so in order to solve this one, we want to look at all three denominators and we want to pick the lowest common denominator for the whole set. What do you think that is? 15? And we're going to multiply both sides by 15. Both sides. This is kind of the complex fraction stuff that we did a long time ago. So let's look at what happens if I multiply both sides by 15. On the far right, I'm going to have what? If I multiply 3/5 by 15, that 5 and that 15 make a what? A 3. 5 and 15 are both divisible by 5. So if I divide by 5, I get a 1 on the bottom and a 3 on top. So what's left? 3 times 3 makes what? 9. Did I lose you, Maisie? No? You promise? Okay. If I multiply each of these terms by 15, what happens in the first? What's left right there? A 5. So this 15 and this 3 cancel and leave me a 5 times that x minus 1. You're following that? If I multiply by the second term by 15, what's left? A 3 times an x plus 2. And we've gotten rid of all of the fractions. Good? So we picked a number that 3 and 5 and 5 all have in common. The lowest number they have in common is 15. Multiply both sides by 15. When I do that, I'm going to multiply each term separately by that 15. So 15 times x minus 1 divided by 3. That's 15 divided by 3, which is 5 times that x minus 1. You seeing that better? Yes. And then I do 15 times this one. 15 times x plus 2 over 5. 15 divided by 5 leaves me 3 times that x plus 2. Is that better? Now we're going to solve it. Okay, I would distribute here. So you got 5x minus 5 plus 3x plus 6 less than or equal to 9. Then what? Okay, combine like terms. So 5x and 3x make 8x. Should I add this 5 to this 6 over here? No, I'm playing devil's advocate right now. Don't do that. You're not crossing the equals sign, right? So you can't add 5 and add 5 here. That's on the same side of the equation. You can't do that. What you can do is say negative 5 plus 6 gives me what? 1. You can combine on the same side of equals. You cannot add them and do all of that switching signs business. is less than or equal to 9. And then what? Subtract the 1. 8x is less than or equal to 8. Divide by 8. Switch my sign. No, don't switch your sign. Why not? Because I didn't divide by a negative. So x is less than or equal to 1. Final answer. X is less than or equal to 1. Okay. I had you graph them on your homework. So if you were going to show that, it'd have to look like this. And then your interval is going to go from negative infinity to 1. You include the 1. Feeling better about this stuff? Yeah?